to start in the test 2 step. And the first thing we're going to talk about is proportions. Proportions are just two equivalent fractions with an equal sign in between them. So we have 2 and 1/2 is equal to 3 over 6. So if we take away one of those numbers, and it doesn't matter which one we take away, we just put an x there. So then the first thing to do is to solve this, the first thing we do is cross multiply. Because that equal sign's there, now we can cross multiply. So we have 1 times the 6 is 6, and 2 times the x is 2x. If you wrote it 6 equals 2x, that's fine too, it'll still work. So after we cross multiply, the next thing we do is divide out whatever this number is in front of the x on both sides to be fair. So we have 2 divided by 2 is 1, so it cancels out. And 6 divided by 2 is 3, so x equals 3, which we already knew from over here. As I said, the x can be anywhere in any one of these spots. So if we have 3 over x equals 7 over 21, we cross multiply. 3 times 21 is 63. X times 7 is 7x. Divide out that 7 in front of x on both sides. So we have 63 divided by 7 is 9. Proportions are good for lots of things. They're good for percents, similar triangles, which we'll get into later, rates, ratios, and lots of other things. First one, since we've talked about percent, we're going to start with percent. Schematic for this is you have a percent over 100 for the first fraction, then your equal signs, and then another fraction with a part of a whole. There are 3 questions they're going to ask you in this section. The first one is worded something like, what is 15% of 72? So if we're putting this into our little formula, we take our percent and stick it over 100. So there's our first fraction. Then anything that comes after the word of goes on bottom. So 72 is on bottom. What we want to know is the x, so we just put it in the empty space. And then we have our proportion all set up, and then we just solve it as we usually do. So we've got 15 times 72 is 1080 equals 100x. Divide out the 100 in front of the x on both sides. X equals 1080. In this instance, just because of the way it's worded, you can do this the easy way and take the full value, the one after the word of, and multiply it by the decimal percent like we did in our chart. So if you change 15% into decimals, it will be 0.15. If you multiply these two numbers, you're going to get the answer. It's only in this specific case the way it's worded. The next one reads something like 27 is 42% of what number? So we've got our percent, 42, and we stick it over 100. Of what number? We don't know. So the x this time has to go on bottom. And the number left over is the part, which is 27, so it goes on top. So we're going to cross multiply. Divide out the 42 in front of x on both sides. X equals 64.29. It's a long decimal, you can run it where you want. And the third kind of question fills in the last space of this. This time we have the part, 44, is what percent of 211? We don't know what the percent is, so the x is going to go over 100 this time. The one after of, 211, goes on bottom, and the part 44 goes on top. So cross multiply, so we have 211x equals 4,400. Divide out the 211. X equals 20.9%. So 44 is 20.9% of 211. And that's all there is to the percent proportion problem. We're going to use these same proportions to solve things in chapter 6. We're going to start with rates, which is actually section 6.2 on page 132, because it's easier than the ratios that start the chapter. Now, rates and ratios are the same kind of thing in that they compare two different numbers. With rates, it can be any kind of unit. The unit is something like feet or yards or miles or hours. This is any kind of units, or you can use dollars for the units. So rates will compare two different kinds of things. So if you have a car and it gets 37 miles per hour and you write the rate, that's 37 miles per 1 hour. And that's all they want for that. So you might be saying, well, what's good is that, and how does that get me to proportions? The most convenient thing of this is what is called Best Buy. Let's see. We got Aaron and he's making barbecue sauce. And it comes in two sizes. 15 ounces for $12.95 or 30 ounces. We'll make it different. 32 ounces for $25.57. And you have to figure out which is the Best Buy. There's an easy way to do this, where you take a price and you divide it by the ounce. And whichever one gives you the cheapest amount is the Best Buy. one is 86 cents per ounce versus I can get my fingers to work. And this is 80 cents per ounce. So this one is the best buy, the cheaper one. Always be careful on your test, because I always have somebody, they do this lovely and then they pick the bigger number. You can also do the same problem with proportions. So you have your first thing, dollars per ounce. You want to know the price per 1 ounce. And again, the price per 1 ounce. You cross multiply. Divide out the number from the x. And you end up with the same problem we did over here. But whatever makes sense to you. We're at the same spot we started over there. X equals 80 cents per ounce. So this one's the best buy. So next thing, we're going to go back to section 4.1 with ratios. Ratios also compare two things, but with the same unit. If they're different, we're going to have to convert one to the other. So we're going to start out with an easy one. They write in several different ways. You can have the word 2, or you can have a colon, or you can have this fraction, and that's the one they're going for in this chapter. So if you have 16 to 1 or 6:1, they want the 16 over 1. There's lots of fun problems with this. The easiest one to talk about is betting. We've got this girl Mary, she's betting $16,854.97, her entire paycheck for the year on this on this horse. Named Robo Lightfoot. Oh, this is her rookie. And gives Mary 12 to 1 odds. We want to know how much she'll win. We always win in this class, it's great. And always for big bucks. You don't piddle around with that small change. So our first fraction in this proportion is going to be our odds, 12 to 1. So if we bet $1, we're going to get 12 back. But we didn't bet 12 out. We didn't bet $1. We bet 16,857. We want to know how much we're going to win. The important thing to remember with proportions is the same kind of thing has to be on top, the other kind of thing has to be on bottom. So in this case, all the wins, how much we're going to win is on top, and all that we've betted is on bottom. You can't put a win bet and a bet win, it won't work out. So now we finally have a proportion, so we're going to solve it. We got 1 times x, which is simply x. You don't have to worry about the 1. And we've got 12 times this number. So, on a good day, at the Kentucky Derby, her little salary there is going to win her $259.64. Not a bad day at the racetrack. So that part's easy with ratios. Then we get to do ratios with conversion. You're going to have something like 12 inches, 6 centimeters. Well, you can't have inches and centimeters in the same thing. So you're going to have to pick one and convert it into the other kind of one. It doesn't matter which one you pick, it will still work. You'll only ever have one of these in my class, and it's going to be a bonus because it's very confusing. To do this conversion, you'll have to have a conversion factor. You either have to know it or it has to be given. I'll give it to you on the test. So the conversion between inch and centimeter is, every inch is the same thing as 2.54 centimeters. So how do you go about converting these things? First thing is you take what you want to convert and you stick it over 1 so it looks like a nice fraction. So in this case we've got, let's take the 12 inches. So we've got 12 inches and we slap it over 1. So there's our first parentheses. Second parentheses has to do with this conversion factor. With what you want to convert, that's called the old units. To get rid of them, you have to cancel them out. So you'll want them to appear on the diagonal bottom here. So you look at your conversion factor. We're starting in inches. So we want the old units of inches to be diagonal bottom here. According to the conversion factor, the thing that goes with inches is 1. The other part is the centimeters. Because it's all multiplied, there's one thing on top, the same thing on bottom. You can cancel the inches, you're left with centimeters. It almost always happens that your new unit comes up in this top right corner. It's not always the case, but it usually is. So now we have 2 fractions and they're multiplied. There's no equal signs here, so you can't cross multiply. So we've got 12 times the 2.54 over 1 times 1. And we're left with the centimeters as units. So 12 inches is the same thing as 30.48 centimeters. That's the first step of these kind of ratio problems. The second part. It's replacing this new number with the 12 and 6 inches over centimeters. We've changed inches into centimeters. So we're changing the 12 into the 30.48 centimeters over the 6 centimeters. Because there's a centimeters on top and centimeters on bottom, you don't really need it. I won't take off if you leave them there. You can use this to convert anything. And actually, this is all about Chapter 8, is converting into different things, metric to standard and whatnot. As long as you have a conversion factor, this same thing applies. So if we wanted to convert 85 miles into kilometers, we take what we want to start out with, stick it over 1. Conversion factors here. We've got miles up here, so we want miles on the bottom there. So for every 0.26 miles, we get 1 kilometer. So the miles are canceled, and we have 85 times 1. 85. 1 times this is, we're looking at the kilometers, so we know we're on the right track. So take the 85 divided by 0.62. We get 137.1 kilometers. Thing we're going to talk about is the metric system. Because we're going to be going from metric to standard and whatnot. Chart. There's only several things you can measure. First thing is length. In the metric system, they use the meter, and its symbol is a little m. The next thing is mass or weight, and its base unit in metric is gram, and has a little g. Last thing is volume or capacity. Its base unit is liter, and you can see it either as a big L or as a little L. These are the 3 basic prefixes. There's a lot more in your book. On page 588. We'll concentrate on these 3 because you're going to see them most often. centi means 100th of the base unit. So if we look at our meter stick, there's 100 centimeters in a meter. Milli means 1,000, so there's 1,000 little millimeters in this meter. And then kilo is means. You take your base unit and times it by 1,000. So if we take the meter and we times it by 1,000, we get the kilometer. And you can go between these. All of its powers of 10, so it's really easy. So you could say, if we have a conversion factor, 1 liter is 100 centiliters. And we want to convert centiliters into liters. We got 82 of them. We want to know how many liters that is. We can do our same little conversion. We got 82 centiliters over 1. So centiliters go on the bottom, and we're left with liters on top. So we got 82 divided by 100. So there are 82 centiliters and 0.82 liters. Once you get used to this, you can see, okay, if that's centi and I divide it by 100, I'm just moving it back 2 places. So either way you want to do it. Conversion factors in this book are scattered through chapter 6 and chapter 8. It's a good metric to English and English to metric on page 609. We also have multi-step conversions. So if we wanted to know what 6 cups to quarts is, and we didn't know the direct conversion, but we knew there's 2 cups in 1 pint and 2 pints in 1 quart. We can still solve this. So we start with what we want to change, 6 cups over 1. And then because there are 2 conversion factors, we're going to have 2 sets of parentheses. So the first one, we want to get rid of cups. So it has to go diagonal bottom. So there's 2 cups for every pint. So cups are gone. We're left with pints. We don't want pints, we want quarts. So we're going to have to go 1 step further. We have pints up here, so we cancel it. You want pints down there. So 2 pints to 1 quart. So now you simply have 6 times 1 times 1. And then 1 times 2 times 2. We have our quarts left, that's what we wanted. 1.5 quarts. Or you could say 1.5 quarts. It doesn't always matter. I mean, it doesn't always happen this way that you start with something on top and cancel by putting on the bottom. You could have something like 62 miles per hour, and you want to know what it is in kilometers per second. So we've got we're going to have 3 conversion factors for this one. So 3 parentheses after the first one. You can either start by changing miles to kilometers or hours to seconds. It doesn't matter which. Because they're all multiplied, you can switch them around. So let's start with the miles. So our conversion factor is 0.62 miles per 1 kilometer. So our miles are gone. So we've arrived at the hours on top this time to cancel it out. So for every 1 hour, there's 60 minutes. We don't want kilometers per minute, we want kilometers per second, so we're going to have to fill in this last one. Minutes are on the bottom, so we're going to have to put minutes on top so they cancel. And the 60 seconds on the bottom. Multiply straight across on top, straight across on bottom. Once you get here, you just do the division, 62 divided by 2232, and you get 0.268 kilometers per second. So if we're going 62 miles an hour, that's the same thing as going 0.278 kilometers per second. I sometimes have bonuses like that. Don't worry about converting temperature, we don't cover that. The formula's there if you want to.